In today's note, we are going to continue to look at the vertex form of a quadratic. However, now we're going to look at going from a graph to an equation. And we're also going to look at examples where we go from a scenario or a contextual problem to an equation. So just as a review, this is our general form of our vertex form. Y equals a, x minus h squared plus k. The a value controls the direction of the opening as well as the step pattern. The h value, or more importantly, the opposite of what we see, is the x value of the vertex, and it's also the axis of symmetry in x equals h. The k value is the y value of the vertex, and this is also known as the optimal value. One thing to note, again, remember that if there is no a value shown, then a equals 1. And if no h and or k value are shown, then h equals 0 and or k equals 0. Because if the only number where I can add or subtract and I don't have to show it, that number is 0. The only number I multiply by where I don't have to show it is 1. So the steps to figure out the equation from a graph or from a scenario, there's two things we need. Or technically 3 variables. We already talked about them, the a, h, and k. The h and k value is straightforward because it comes from the vertex. And the vertex is basically the point hk. The next thing we need is the a value. And there's 2 ways we can find the a value. One, we can use the step pattern to determine the a value, using that 1a, 3a, 5a, figuring out what our steps are, and then kind of working backwards to this pattern. And quite simply, if I look at this first step, 1a basically just means a. So that first step, whatever that first step happens to be, that's going to be our a value. So if our first step is 1, our a value is 1. If it's -2, then our a value is -2. Whatever that first step is going to tell us our a value. The other way, if we're not given the step pattern or we're not given a graph to find the steps, we can use a point, x and y, to algebraically solve for a. And we'll work through a couple of those examples as well. So the first thing we want to do is, given these graphs, or given this information, I want to determine an equation for the quadratic. So looking at my first example, I need to find my vertex. My vertex is right here, lowest point in this case, and this vertex is -4, -4. So from that, I can tell that my h value is -4 and my k value is -4. The next thing I need to figure out is, what is my a value? And in order to do this, I just need to use my knowledge of the step pattern. The step pattern tells me that I have to move from the vertex, I move 1 to the right, and then I go up my first step until I hit my graph. In this case, my first step is 1. It looks like 2 squares, but look at the scale, see what you're actually going up by. So I go over 1 from the vertex and then up 1 till I hit my graph. So that means my first step is 1. If I want to figure out my next step, I go over 1 again. Again, looking at the scale to make sure I go over 1. And then I go up. Oops. Try to do as straight as possible. You go up until you hit your graph. That's your next point. What are my steps for the next, or what's my step here? In this case, I've gone up 3. So right now I know my first two steps are 1, 3. I can't find my third step from the graph, but I have more than enough to fill in or find my a value. Remember, the general form is 1a, 3a, 5a. So looking at this, I have to think, well, what a value do I multiply 1 by to get to 1? What a value do I multiply 3 by to get to 3? The only value that works, because remember they have to be the same a value, the only value that works is 1. 1 times 1 is 1, 3 times 1 is 3. And this happens to be the first step. So the first step was 1. My a value is 1. And now I can put all of that together and fill in my general form, y equals ax minus h squared plus k. Again, I know my a value now, it's 1. I don't have to show it, but I am just going to show it so I know where to put it for future reference. X, I don't need to worry about. H is negative 4. So if it's x minus negative 4, I can actually rewrite that as x plus 4. Which makes sense because we talked about the h value being the opposite of what we see in the bracket. Here I see plus 4. In actuality on my graph, it's minus 4. So that works. Then k value is minus 4 as well. So here is my equation for this quadratic. Moving over to example 2, we're going to do the exact same thing. We're going to find the vertex, which in this case is 4, negative 2. So we know our h equals 4, our k equals negative 2. And we're going to use the step pattern to help us find our a value. So I start at my vertex, I move over 1, and I'm going to go up until I hit my graph. I've hit my graph. What distance is that first step? It's 2. Right off the bat, I could stop because I know that the a value is that first step, or it's 2. If I want to double check, using that 1a, 3a, 5a pattern, based off of this, if I know my first step is 2, guessing that my a value is 2, the next step should be 6. So if you want to test that, go over 1. I'm going to go up until I hit my graph. I hit it there. That is an increase of 6. So that a value of 2 is following this pattern. So I'm correct with my a value being 2. But again, it always works that the first step is your a value. I'm going to plug all that information into my general form. So y equals a value of 2, so 2x minus 4. It's a positive 4, so when I subtract a positive, nothing changes. Squared minus 2. And there is my equation of this parabola. So 3 and 4 are looking at the exact same thing. Right? So I'm going to suggest that you pause the video to try to do these two on your own. Again, find the vertex, find the step pattern to help you find that a value, and then plug it all into that general form. So I'm going to pause the video for a second, and then you're going to try this on your own. So coming back to example 3, this is what your solution should look similar to. We should find that our vertex is negative 4, negative 3. So our h value is negative 4, our k value is negative 3. Finding the step pattern, looking at that first step, we should see that it's negative 2. We move to the right 1, then draw our line down until we hit our graph. Because we've gone down, that step has to be negative, and we've gone down 2 units. We can double check with our second step. It should be negative 6 if we follow that 1a, 3a, 5a pattern, and in this case it is. So taking that a, h, and k value, we plug it into the general form, and we get y equals negative 2, x plus 4 squared minus 3. For example 4, same idea. Find the vertex, 4, 1, which means our h value is 4, our k value is 1. Use the step pattern to find our a value. This may be a little different because our a value in this case is a decimal. But we're using the same steps looking at our graph. Move 1 to the right, go down until we hit our graph. So in here, in this case, because we go down, it's negative, and we should see that we go down 0.5 for our first step. So right off the bat, that first step tells us that a value. If we wanted to double check to make sure our pattern does work, we can see that our next step is negative 1.5 and negative 2.5. So this does fit that pattern of 1a, 3a, 5a when a is negative 0.5. Taking all of those values, plugging them into that general form, we get our equation of this parabola or quadratic, which is y equals negative 0.5 x minus 4 squared plus 1. The next example we're going to look at, example 5, here we don't have a grid really to help us use the step pattern. So what we're going to do in this case is we still have our vertex of 0, 0. So this tells me that h is 0 and k is 0. But now, given the point 2, 1, I have different information. I have a point which tells me an x and a y value. So in this case, I don't have an a value yet, but I know x equals 2 and y equals 1. So in my general form, y equals a x minus h squared plus k, what I'm going to do to solve for my a value is plug all this information in and then solve algebraically. So I'm going to sub in h, k, x, and y, and then solve for a. So by plugging all that information in, y is 1, a I don't know, x is 2, minus 0 squared plus 0, 1 equals a times 2 squared plus 0. I don't even need to show that plus 0. 1 equals a times 4. So keep in mind you do have to follow BEDMAS for this, so just make sure you do that. To get a by itself, I'm going to divide the one side by 4, divide the other side by 4, and I get 1 over 4 equals a. Now I have my a, h, and k value, so I can put this all together. Y equals 1 over 4 x, because it's minus 0 squared, I can just do x squared. I could add in the plus 0 for the k, but I don't need to show that either. So then this is my equation of the quadratic for this parabola. Number 6 is the same idea, except now we're not given a graph at all. We're just told the vertex, negative 3, 7, which tells me h is negative 3, k is 7, and it tells me that this quadratic goes through the point negative 2, 5. Again, similar to the last one, even though we don't have a graph, we have a point which tells me an x and a y. So that means, given my general form, y equals a, x minus h squared plus k, I can sub in my h, k, x, and y, and then solve for a. So plugging all of this in, y is 5, a is unknown, x is negative 2, minus h, or minus negative 3, becomes plus 3 squared plus 7. Now I'm going to start to simplify things using BEDMAS. I'm going to use my brackets, so negative 2 plus 3 is 1 squared. 5 equals a times 1, or 1 squared is 1, a times 1 is just a. I'm going to cancel out the 7 by subtracting 7. 5 minus 7 is negative 2 equals a. And there is my a value. Now I can rewrite my general form, plugging in the a, h, and k. A is negative 2, x minus negative 3, or minus h, but minus negative 3 becomes plus 3 squared, and then plus k, or plus 7. And there is the equation of this quadratic. with a vertex of negative 3, 7, and going through the point negative 2, 5. The next couple examples that we're going to look at all involve word scenarios. And these are going to be a little bit different because we need to visualize what is actually being shown, or the path or the scenario, in order to find our vertex and our 2 points. So if I want to graph this situation, which is a child kicks a soccer ball so that it barely clears a 2-meter fence. The soccer ball lands 3 meters from the fence. Determine the equation in vertex form of a quadratic relation that models the path of the ball. So if I'm going to draw a rough scale, I have the height of the ball and the horizontal distance of the ball. Now I need to graph or plot in a couple points and roughly sketch this. So this is going to take some thinking. This is probably going to be the more challenging part. But I know that the ball barely clears a 2-meter fence. So this has to be my maximum. If it barely clears it, that's got to be the highest it goes. So the highest my ball goes is 2 meters. So I'm just going to put in 2 meters or 2, and I know that's going to be the highest it goes. The other piece of information is that the ball lands 3 meters from the fence. If the ball lands 3 meters from the fence, and the fence is this maximum or this middle value, that means it must have been kicked 3 meters before the fence. Right? In terms of symmetry, right, the quadratic or the parabola is symmetrical. So that means if I have my fence at a certain value, right, if we wanted to roughly just draw in a fence here, if I want to draw in my fence, that means if the ball lands 3 meters from it, it had to have been kicked 3 meters before it, because this is my vertex, or my maximum height. So 3 meters from the fence, 3 meters before the fence, that means my final distance has to be 6 meters from where I kicked it. That means this fence is right in the middle at 3. So I have a vertex of 3, 2. If I wanted to plot this, it's going to look something like that. There's the ball, or the soccer ball. So it gets kicked from the ground, barely clears this fence at its highest point, and then lands 3 feet from the fence. It's symmetrical from the vertex, so we have enough information here. I have my vertex, which is a point, but I'm missing another point, but luckily I have 2 of them. I'm going to use the one here that I know for sure, 6, 0. So I know my h is 3, my k is 2, my x value is 6, and my y value is 0. So plugging this all in, same idea as before. Y equals a, x minus h squared plus k. Plug in all my variables and solve for a. 0 equals a, 6 minus 3 squared plus 2. 0 equals a, 6 minus 3 is 3 squared plus 2. 0 equals a times 9 plus 2. To get rid of the 2 on the one side, it's going to move to the other and become minus 2. A times 9. Divide both sides by 9. One side cancels out, and we left with negative 2 over 9 equals a. So now putting this all together in my general form, y equals negative 2 over 9 times x minus h, or minus 3 squared, plus k, which is 2. So this one may have been a better candidate for solving it algebraically, because we could tell by that a value that would have been messy and tricky to try to graph that or try to use that step pattern if we wanted to plot this actually on a grid. But we know how to do it algebraically, and we've come up with an equation for this quadratic. So example 6, I'm going to pause after I read the question to let you try to come up with a solution for this. Actually, we'll probably try to draw this out first and then let you try to reason through it. But the Lions Gate Bridge in Vancouver, British Columbia is a suspension bridge that spans a distance of 1,516 meters. Large cables are attached at the top of the towers 50 meters above the road. The road is suspended from the large cables by many smaller vertical cables. The smallest cable, or the smallest vertical cable, measures about 2 meters. Use this information to determine a quadratic model for the large cables. So basically, the suspension bridge, we have, say, one tower here. The large cable drops and it connects to another tower. So if we want to graph this on a grid or on a rough sketch, we have our height and we have our horizontal distance. There's some key information that we have from this question. One is that it spans a distance of 1,516 meters. So that means this last point here is 1,516 meters from the initial. Right, so initial here is 0. We know the height at the two towers is 50. And we know that the smallest vertical cable measures 2 meters. So if you imagine we have vertical cables that are connecting it to the base all the way along, the smallest vertical cable is 2 meters. So that means that in the middle, that has to be where our minimum is. So that height of 2 has to be right in the middle. Because it's symmetrical on both sides, that vertex is in the middle, that maximum or minimum value has to be in the middle. So this minimum value has to be in the middle. What's the middle? We know our overall distance, so we know that the middle is going to be halfway between that. So the middle is 758. So there we have enough information now to write our vertex. 758 and 2. We have another point of 1,516 and 0, or sorry, not 0, and 50. We have another value of 0 and 50. So we have plenty of information, plenty of points, and the vertex to help us come up with an equation. So H is 758. K equals 2. X, if we use, let's just say we're going to use the last point. And Y is 50. So I'm going to pause the video and let you try to work through the rest on your own. But again, the rest of the steps should be fairly straightforward with what we've done previously. So once we plugged in our h, k, x, and y values, simplified using BEDMAS, and then solved for a using our algebra, we should have gotten an a value of 0.00084, which would equal A. So then when we plug our A, H, and K into our vertex form equation, here we see in purple the equation of a quadratic model that represents the large cable. So if we were to graph this, this should represent our large cable. So we should see a graph that has this general U shape. It has a low point of 758 and 2, and we should see that it crosses the points nicely at 50. For number 7, it's going to be roughly the exact same thing. So here what I'm going to do, I'm going to help you come up with the drawing for it, and then I'm going to let you try to figure out the rest and come up with the equation on your own. And then the second part B wants you to use that equation to find the height of the rocket. So a model rocket is launched from the ground. After 20 seconds, the rocket reaches a maximum height of 2,000 meters. It lands on the ground after 40 seconds. So this one's a little bit more straightforward. If we're going to roughly draw our grid or our graph, we know it launches from the ground and then lands. We're told it lands on the ground at 40 seconds. We're told that it reaches a maximum height of 2,000 at 20 seconds. So that tells us our vertex is 22,000. And we know our another point over at the bottom at 40 and 0, because again, if our height and our time, we know if it's hit the ground, then the height is 0. So using this information, come up with an equation to model the rocket's path, and then use that equation in B to figure out what would the height of the rocket be after 30 seconds. Again, I recommend you pause the video, try to do this on your own, and then we'll come back with the solution. So coming back to this last example, using the vertex or the maximum height and the time it took to reach it, 20 and 2,000, using the point when it landed, 40 and 0, we would have an A, H, and K value, which we could plug into the equation or the general form to solve for A. We should have found that going through and solving it, that we got an A value of -5. So if we plug that into our general form, the equation to model the rocket's path would be y equals -5 times, in brackets, x minus 20 squared plus 2,000. We can then use that equation in B to find the height of the rocket after 30 seconds. The time represented the x value, so instead of x, I can sub in 30. So this is basically saying x equals 30. And then I can solve for y, or the height. So by doing that, I should have found that I have a height of 1,500. So that means that after 30 seconds, the height of the rocket is 1,500 meters. So again, look, many different examples that we looked at in this lesson. The key thing is using the vertex and either the step pattern or a point to solve for the A value. Once you do that, you can plug it into your general form, that A, H, and K value, and come up with an equation that models the quadratic or the parabola that you see. And we can use that equation if we want to find other values on our quadratic, similar to that last example, or we can just have it as a model that represents the general path or the general shape.